In previous video, we have seen how to plot the graph for trained mean square error and a test mean square error. In this video, we are going to learn how to use the cross-validation as a test option for linear regression modeling. Okay. So before we start, we have to ensure that these libraries are installed on your system. So we'll try to run this library. So caret, glmnet, mlbench, and psych. So please ensure that these libraries are already installed on your system. To know what default datasets are available in R, you can use this line. You can use this function data. So this will show you what are the default datasets available in R. Okay. So I'm going to use the Boston housing dataset, which is the default dataset offered in R. Okay. I'll try to copy this Boston housing dataset into a data frame object called data. So in data, I have the Boston housing dataset. And if you want to know the details of this dataset, you can just run this line question mark followed by the name of dataset, which will give you the short description about the dataset in this window. It will take some time. So it will give you the description, the usage, the format, and source and references for this dataset. Okay. So I'm going to skip this step of splitting the dataset into test and train, because this time the test option that we are going to use would be a cross validation. We know what is the cross validation. Okay. We split the dataset into different partitions, and then we apply the machine learning model on each partition of the dataset. This process, what we call, is the cross validation. Okay, so to create a cross validation test option, we have to use the function called train control. So to this function, we are going to pass the first parameter, which is nothing but the method. Okay, you can pass two values to this first parameter, first argument method. That is, one is CV and other is repeated CV. If you pass the argument CV, then you don't have to specify the repeat parameter. Okay, so if you are passing repeated CV parameter, then you have to specify the repeat number of repeats. Okay, so here I am using a plain CV method, that is cross validation method. So I have to only specify the number of folds that I want to create for this data set. Okay, so I have specified the number of folds to be 10, and the verbose setter is set to true. Okay, we're going to run this line. Okay, so using seed function, you can choose any random number. Okay, so your number generation will start from this point. This is what the seed function indicates. Then after that, we are going to create the linear model for the Boston housing dataset. Okay, so I'm going to use the train function. So to this train function, I'm going to pass this median values. So this medv till dot, it indicates that I want to use all the variables of the Boston housing dataset to create the linear model, whereas this medv, it indicates that I want to normalize all these variables chosen to create the linear model. Okay, followed by the first argument, followed by the name of dataset. So I am using Boston house dataset. The method I am using, that is the model that I want to create, would be a linear model, and the train control parameter. Okay, so training control parameter would be custom. Now custom is the object in which we have our cross validation option. So I have passed this object to this train control parameter. So if you run this line, okay, then we'll try to find out what would be there in the linear model, because we have created a linear model, okay, using cross validation option, okay, test option. Fine. So we'll try to see what are the results of LM. So LM $results will give you the results of linear model. So my intercept, this is my intercept, this is my RMSE value, this is my R square value, this is mean absolute error, this is RMS SD standard deviation, R square standard deviation, mean absolute error standard deviation. So this is what the result. Can just run LM to show the summary of it. So this linear model, it has 506 samples. That means it has 506 data points or 506 instances, whereas it has 13 predictor. That means it has 13 variables, or the data set has 13 columns. Okay. So resampling, for that purpose bootstrap method is used, whereas there are 25 repetitions. The summary of the sample sizes are 506, 506, 506. So there are, if you remember, in cross validation, the number of repetitions are, you can say 10. Okay, we can have the 10 partition of the Boston housing data set, and this is the result of resampling, where this is the root mean square error, this is the R square error, and this is the mean absolute error. Whereas the tuning parameter intercept was held constant at the value of true. Okay, so let's see the summary of this. Okay, so this will give you the intercept, this is the standard error, this is the t value, and this is the probability value, that is p value. Okay, so the intercept, that is the value of beta 0, it is 3.64, whereas the value of the beta 1, which is the first column of your data set, that is cream column, the column with the name cream, and thus it is represented with the coefficient beta 1, which has the value minus 1.080. So same as for the second variable, that is second column, so it is beta 2, it has the value of 4.64. So on, we have the last variable L statistics, which has the value 5.24. Now these are the asterisk symbol, and we have seen what is the use of this asterisk symbol, what this asterisk symbol represents, so in the previous video. So in nutshell, if we want to conclude, this asterisk symbol, it suggests the significance level of each variable. The 3 asterisk symbol, it indicates that the variable has the high confidence or high contribution in building the machine learning model. And you can see this variable index, it do not have any asterisk symbol. That means it has a 0 contribution in building the learning model. Okay, so this gives me the useful information that even I can build my model using this cream variable, then this anox variable, RM variable, age distribution, and finally this last 3 variables, P, PTR ratio, PT ratio, then B and L stat. Because all these variables, they have 3 asterisk symbols, that means they have very high contribution, they have the high significance level in building the machine learning model. And rest is, these are the standard error 4.74. This is the R square error and adjusted R square error. I have already explained what is the use of this R square error and adjusted R square error in machine learning. So this values of R square and adjusted R square, it implies that your dependent variable has, your model explain the variability of your dependent variable using these 2 values called R square and adjusted R square. Thus it means that higher the R square and adjusted R square, better would be your model. This is what the interpretation from this value. If you have the high values for R square error and adjusted R square error, that means your model would be very better. Okay, then we'll just try to plot this model. Okay, just hit run. So this is the first plot. So this is the plot which is against residual and fitted value. So y-axis represents residuals, whereas x-axis represents your fitted values. And this is this red line indicates my regression line, which best fits all the instances on this input instance space. The same way, we can also create a plot for normalized versus standardized residuals, as well as the scaling location versus standardized residuals, and finally the residual versus leverage plot. So this is my linear regression line that best fits this. We are just leveraging the linear regression model, okay, versus residuals, whereas these dotted lines, these are nothing but the cook distance to this linear regression line. So that's all from linear regression using cross validation. In next video, we'll see how we can apply the subset selection method in linear regression model. Thank you.